Welcome to this explainer. Have you ever hit that frustrating plateau in your coding journey and wondered what actually separates an everyday intermediate programmer from a true, absolute engineering master? Well, you are exactly in the right place. Today, we're decoding the definitive 20 expert-level concepts to help you totally shatter that plateau. We're going to take these highly technical requirements and translate them into a crystal-clear, aspirational roadmap. We're talking about going from writing isolated functions to engineering massive, globally distributed systems. Let's get into it.
So, what exactly makes a developer an expert? It's a question we hear thrown around a lot in tech circles, isn't it? Really, it's the difference between just building a feature that works and architecting a resilient system that can effortlessly serve millions of users without buckling under the pressure. Making that jump requires a huge cognitive shift. We aren't talking about basic syntax or beginner tutorials here. No, we're focusing purely on the heavy-hitting concepts that define the absolute upper echelons of software architecture and data delivery. Mastering these, it completely transforms you from a code contributor into a technical visionary.
To break this all down, here's our thematic blueprint for today. First up, structural architecture. Then, rendering strategies. Third, quality standards. And finally, we'll bring it all together in the complete picture. All right, starting right off with Pillar 1, structural architecture.
The real foundation of engineering mastery begins with structural design. Specifically, we're looking at design patterns, micro-frontends, monorepos, and ultimately scalable architecture. Look, an intermediate developer writes code to solve an immediate problem, right? But an expert architects entirely new ecosystems. And this starts with a deep understanding of established design patterns. Why reinvent the wheel when battle-tested solutions for object creation, component communication, and state management are already out there? When you truly internalize these patterns, you drastically speed up development and literally eliminate entire categories of bugs before they're even typed out. It's all about organizing complexity so that as your codebase grows, it doesn't just collapse under its own weight.
Now, as you walk this expert path, you're often forced to make a crucial architectural choice: micro-frontends versus monorepos. Micro-frontends break massive applications down into smaller, totally independent pieces. This gives you ultimate autonomy. Different teams can deploy their specific features without waiting around in some massive, slow, unified release cycle. On the flip side, monorepos keep all your code unified in a single repository. This approach vastly simplifies dependency management, makes code sharing across your projects an absolute breeze, and ensures unified versioning. But here's the thing. An expert doesn't just blindly pick whatever option is trending. They understand the profound trade-offs of both. They know exactly when an organization's scale demands the isolation of micro-frontends and when the tooling friction demands the centralized control of a monorepo.
So mastering all these varying design patterns is fundamentally in service of one overarching goal: achieving true scalable architecture. And in practice, scalable architecture means your system can dynamically handle a sudden massive spike in Black Friday traffic just as efficiently as it handles a quiet Tuesday morning. But, and this is key, it also means scaling on a human level. Can your architecture smoothly onboard 100 new developers without them stepping all over each other's toes in the codebase? True scalability dictates that both your server infrastructure and your human engineering workflows can expand entirely without friction. That's exactly why it sits as the ultimate goal of structural design.
Moving right along to our next section, Pillar 2, rendering strategies. Here, we matrix out SSR, SSG, ISR, and React server components to build a highly organized, almost scientific toolkit for delivering data to the user. Experts don't view these as just simple coding preferences. No, they see them as absolutely critical levers to optimize the end-user experience, specifically targeting heavy-hitting metrics like time to first byte and time to interactive. Server-side rendering, or SSR, is your go-to when real-time dynamic data is non-negotiable for every single request. Static site generation, SSG, is utilized for pages where lightning-fast, pre-built delivery is paramount. Think marketing sites or blogs. True expertise lies in choosing the absolute best delivery method for the specific performance problem you're facing, ensuring the user gets their data seamlessly.
But navigating beyond those basics into incremental static regeneration, or ISR, and React server components, that is a defining hallmark of expert-level understanding. ISR is honestly revolutionary because it gives you the best of both the static and dynamic worlds. It lets you update incredibly fast static pages in the background after they've been built without ever requiring a full site rebuild. And then we have React Server components, which completely shift the traditional client-server boundary. By rendering components exclusively on the server, you keep heavy dependencies entirely back-end side. We're talking about shipping literally zero JavaScript to the client for those components. Understanding the profound performance implications of these newer paradigms is exactly what elevates you from a good developer to a truly elite engineer.
That brings us to Pillar 3, quality standards. As you can see here, accessibility, often referred to as 11Y, security best practices, and web performance carry equal weight in expert engineering. Notice how performance isn't prioritized over accessibility, and security certainly isn't treated as a last-minute afterthought. At the expert level, they sit completely side by side. You simply cannot sacrifice one for the other. This equal prioritization represents a real maturation in engineering philosophy. It's the recognition that a blazing fast application is completely useless if it exposes user data, and a highly secure application is a massive failure if it fundamentally excludes users with disabilities.
The reality is, an application isn't truly finished unless it meets these 3 uncompromising quality standards simultaneously. Think about it. If your beautifully architected app ignores accessibility, you are actively shutting out a massive portion of your potential user base, not to mention inviting serious legal risk. If it lacks security, well, that's just a ticking time bomb for a catastrophic data breach. And web performance has direct, measurable business impacts. Major e-commerce giants have proven time and again that even a 100-millisecond delay in page load time can literally cost millions of dollars in lost revenue. This trio, accessibility, security, and performance, provides the mandatory professional polish of the expert tier.
Now, let's tie it all together in our final section, the complete expert picture. When we take a step back, all these daunting terms transform into a really neatly categorized curriculum. More importantly, though, an expert sees exactly how these 3 pillars interact and depend on one another. It's like a giant puzzle. A pristine structural architecture enables you to easily swap rendering strategies without rewriting your entire codebase. Those advanced rendering strategies directly fuel your core quality by inherently improving web performance. And robust quality standards? They actually dictate the guardrails of your initial architectural design. This is a holistic, full-stack ecosystem where every single technical decision you make ripples outward, impacting the entire lifecycle of the application. So those are the exactly 11 core concepts you absolutely must master. Now, it's really important to acknowledge that truly internalizing these domains is a career-long pursuit. It's definitely not something you just pick up from a single weekend tutorial. Each of these 11 areas requires deep, focused study, plenty of trial and error in real production environments, and a relentless curiosity to understand the underlying mechanics of modern web engineering. Grasping the sheer scope of this 20 expert-level concepts list is your crucial first step toward mastery. Look, I know it can feel overwhelming at first, but remember, the specific hurdles we've demystified today, you're navigating the organizational trade-offs of monorepos versus micro-frontends, you're implementing zero-bundle React Server components to maximize performance, you're demanding rigorous, baked-in accessibility from day one. By breaking these concepts down into clear, actionable pillars, that imposing mountain of expert engineering suddenly becomes a navigable, structured pathway upward. You now have the blueprint. You know the exact 11 concepts that separate the everyday intermediate developer from the absolute expert. The map is officially drawn. So looking at everything we've covered today, the only question left for you is which of these expert concepts will you conquer next?